Good evening, all. Welcome to Sankalp learning classes. So, we were discussing the chapter 7, integrals, and we have already discussed 8 types of integration, isn't it? We have that is in integration by substitution itself. We have divided into 7 type, and including direct integration, we studied it. We studied 8 types of integration. Okay. Now, in today's session, we'll be discussing the 9th type as well as the 10 type. Okay, there are in total we can divide it into 10 methods. In total there are 10 methods of integration. So we'll be discussing the type 9, type 10, and we'll be completing this chapter today. Okay, you have another portion also, it's called definite integral. So we'll be discussing all these topics today. Let's start with the 9th type. Okay, the 9th type is, so in the first class itself, I have told you that we can divide this integration method mainly into 3 categories. That is integration by substitution, then integration by partial fraction, and the third one is integration by part. So today we are going to discuss the method called integration by partial fraction. Okay, what is it called? Integration by partial fraction. Okay, so this is it. So how will you identify? So identifying our question, that is how to, which method to use for integration, that is very important, right? So how to identify the questions or the functions that uses integration using partial fraction. How will you identify? So there are certain conditions that is given here. The function should be of the form f of x by g of x. First condition is that the function should be of the form f of x by g of x. And what is this function called? Functions of the form f of x by g of x is called as a rational function, isn't it? It's called a rational function. So, first of all, this should be of the form f of x by g of x. This is the first condition. And the second condition is that the degree of f of x, the degree of f of x, the degree of the function f of x should be less than the degree of g of x. Okay, degree of f of x should be less than the degree of g of x, which means the degree of the numerator should be less than the degree of the denominator. All right. Okay. Now the third condition is that this denominator g of x should be, we should be able to split into g of x can be factorized into linear factors or quadratic. Okay, linear or quadratic factors. So what are the conditions? First, it should be of the form f of x by g of x. Then second condition is degree of f of x. The degree of numerator should be less than that of the denominator, and the denominator should be factorized into linear factors or quadratic factors. Okay, so these are the conditions. If this condition is not satisfied, then such fractions are known as improper fraction. And what we have to do, to convert this improper into proper, we divide the fraction, right? That is using long division method, we divide it and we convert it into a proper fraction and then solve it. Okay, this is a theoretical part, and there are 3 different types in this session itself. So we will discuss that and we'll do a problem from this. Okay, so here the first one is here it is of p of x by q of x form. This is the first one, that is px plus q by x minus a into x minus b. So if you get a function like this of the form px plus q means it is a linear polynomial. Here you can see that this is also a polynomial, isn't it? It is given as 2 factors, x minus a into x minus b. Isn't it? It is a quadratic polynomial, but it is given as product of its linear factors, that is x minus a and x minus b. Okay, now you check whether the conditions are satisfied. Here you check, this is the power 1. Linear polynomial means the power of x is 1. So degree of f of x is equal to 1 in the first case. And here you can see what is the degree of g of x, the denominator. What is the degree of denominator? Here if you multiply x into x, you will get x square. So what is the degree of g of x in the first case? It is 2. So here you can see that the second condition is also satisfied. Degree of f of x is less than degree of g of x, and g of x is a product of two linear factors. So we can apply the method partial fraction. So what do you mean by this partial fraction? Partial fraction is nothing but if you are given a single fraction like this, it will be very difficult to integrate that function because it's a product of two linear factors, isn't it? So we'll just convert the single fraction into two or more fraction. Okay, we'll convert this single fraction into two or more fractions. That process is known as partial fraction. Okay, so we are going to convert this question into partial fraction, this term into partial fractions, and then it will be easy for us to evaluate the integral. Okay, so how we are going to convert, that is important. Each type you have to study how you should convert it into partial fraction, and it is very easy also. Okay, so you can see here there are two factors, x minus a and x minus b. Okay, so how will you convert this into partial fraction? You write a constant. A and B are constants. You write A by x minus A plus B by x minus B. So we splitted this product of factors into sum of factors. All right. Now you take the second question. These are all satisfies the conditions. It is of the form f of x by g of x. Degree is less than numerator's degree is less than that of denominator, and denominator is either product of linear factors or quadratic factors. All right, so here it is, you can see that it is just x minus a the whole square. So if it is just x minus a the whole square, how will you split it? It is a by x minus a plus, not b. Again, you don't write b by x minus a. If it is the same factor, here it is distinct factors. A and b are separate factors. Here you can see that a is repeating. The factor a is repeating. So x minus a the whole square. Right. So you have to write a by x minus a plus b by x minus a the whole square. Now you consider the third one, px plus q by x minus a the whole square into x minus b. Okay, so how will you split this? A by x minus a plus b by x minus a the whole square. Here x minus a the whole square, you should not write b by x minus a. It's a. Okay, you should write b by x minus a the whole square. Okay, that is a common mistake that students make. Then third one is there is another factor, that is x minus b, that is plus c by x minus b. Okay, now you move on to the last type, that is px plus q by x minus a into x square plus bx plus c. Here what is the peculiarity? One is a linear factor and the other one is a second degree polynomial. It is a second degree polynomial, but this cannot be further factorized. Okay, it cannot be splitted into linear factors. Okay, so that's why it's written as a quadratic polynomial itself, that is x square plus bx plus c. In such cases, what you have to do is that the first one is as above, that is a by x minus a itself, plus here you can see this is, since this is a quadratic polynomial, here you should write a linear polynomial as the numerator, that is bx plus c. Bx plus c divided by x square plus bx plus c. Okay, so these three are important. This one is actually a repeating type. So these three you have to study the forms of partial fractions. All right, now we'll do a question from this. Integral x by x plus 1 into x plus 2 dx. X plus 1 into x plus 2 dx. Okay, so this is our first question. First, what you have to do? You have to identify which method to be used. So here it is of the form f of x by g of x, f of x by g of x, where f of x and g of x are polynomials. Isn't it? X is a polynomial, x plus 1 into x plus 2 is another polynomial. Right. Now what we have to check? Whether the degree of f of x is less than degree of g of x. Degree of f of x should be less than degree of g of x. What is the degree of f of x? What is the degree of f of x? Degree is nothing but the power of x, isn't it? So it is 1. Now, what is the degree of g of x? G of x is written as a product of linear factor. So if you multiply like this, It's actually x plus 1 into x plus 2. If you expand it, you will get a quadratic polynomial, right? X into x, that will be x square. That is the highest term of x, right? So what is the power of x here? What is the power of x here? It is 2. So degree of g is equal to 2. Okay, so the second condition is also satisfied. That is degree of f of x is less than degree of g of x. All right. Now, what was the third condition? G of x should be factorized into linear or quadratic factors, right? So here you can see that this is a product of linear factor. X plus 1 is one factor and x plus 2 is the other factor. So that polynomial is written as a product of two linear factors. So three conditions are satisfied. So we can apply which method? Integration by using partial fraction. Okay, so which is the type within the partial fraction? The first type, isn't it? It is of the form px plus q by x minus a into x minus b. So how will you convert this into partial fraction? How we can convert this into partial fraction? Right, x by x plus 1 into x plus 2. Okay, so this is equal to x by x plus 1 into x plus 2 is equal to a constant a divided by first factor a by x plus 1. What is the second factor? X plus 2. So b by plus b by x plus 2. Now we have changed the product of factors into sum of factors. That is, we wrote the partial fraction form. Okay, now what we are going to do is that we are going to multiply throughout. Okay, that is this equation. We are going to multiply throughout by x plus 1 into x plus 2. Why did I choose x plus 1 into x plus 2? Here the denominator is x plus 1 into x plus 2. So I am going to multiply throughout with x plus 1 into x plus 2. Now what happens if I multiply this term? Okay, that is x by x plus 1 into x plus 2 with x plus 1 into x plus 2. What will happen? It will get cancelled, right? These two terms will get cancelled. So what is remaining in the left side? It is only x. Okay, only x is remaining. Now what happens if I multiply this portion? A by x plus 1 into x plus 1 into x plus 2. What will happen? This x plus 1 and x plus 1 gets cancelled, right? So this will become a into x plus 2. The second term will become a into x plus 2. Now what happens to the third term? Can you say what happens to the third term? Third term also I am multiplying it with b by x plus 2, multiply it with x plus 1 into x plus 2. So what happens? X plus 2 and x plus 2 gets cancelled, right? So this become b into x plus 1, b into x plus 1. All right. Now the task is that to find the values of these constants, values of the constants a and b. So how will you find the values of the constants a and b? Yesterday we discussed a method, right? Here it is much easier to find out the constants a and b. Here what I'm going to do is that if I put minus 2 in the place of x here, okay, if I put x equal to minus 2, what happens here? This will become minus 2 plus 2, isn't it? This term. Okay, observe this term. That term will become minus 2 plus 2. Minus 2 plus 2 is nothing but 0, right? So 0 into a will become 0. 0 into a will become 0. So that terms gets eliminated. So what is remaining there? What will be remaining there? Only this term, right? Only this term. Okay, so from that we will get the value of the constant b. Now, in the second part, you put x equal to minus 1. X equal to minus 1. So, minus 1 plus 1 will become 0. 0 into b is 0. So, that b term will get eliminated. So, we'll get the value for a. Okay. So, that is the process that I'm going to do. So, first I'm going to put x equal to minus 2. X equal to minus 2. So, in the left hand side, there is only x term. So, that will become minus 2. Minus 2 is equal to a into minus 2 plus 2 plus b into minus 2 plus 1. Okay, so this is equal to, so this will become, okay, minus 2 is equal to, the first term will become 0. Then that was b into minus 2 plus 1, right? What is minus 2 plus 1? The value of minus 2 plus 1 is minus 1. So it is minus b. So what is the value of b? B is equal to 2. Now put x equal to minus 1. So what will be the answer? Left side, it is minus 1, x equal to minus 1. Then a into x plus 2, right? So minus 1 plus 2 plus b into minus 1 plus 1. Okay, so minus 1 is equal to, this will become minus 1 plus 2 is 1, right? So a, then this term becomes 0. So a equal to minus 1. We have got the value as a minus 1 and b as 2. Now come back to the question. So we have written this integral x by x plus 1 into x plus 2 as partial fraction, that is a by x plus 1 plus b by x plus 2, right? Now we have got the values for a also. A is minus 1, so it is minus 1. It is minus 1 divided by x plus 1 plus, okay, so there is integral also, integral minus 1 divided by x plus 1 plus 2 by x plus 2. The value of b is 2, right? Dx. Now we can split it. The property of indefinite integral, that is we can split it, right? So this will become integral minus 1 by x plus 1 dx plus 2 into integral 1 by x plus 2 dx. Okay, so this can be written as, what is the integral of 1 by x plus 1? If it was 1 by x, we know it is log mod x plus c. Log mod x plus c. Here in the place of x, it is a linear polynomial x plus 1. So we can assume it as x and do the integration normally, but we have to divide the derivative of the linear polynomial. Here, you know, the derivative of this linear polynomial is nothing but the coefficient of x. It is 1 itself. Here also, the derivative will be 1. So you can directly write the result, right? So here there is already a minus. So minus log mod x plus 1 plus here there is already 2. Then the integral of 1 by x plus 2 is nothing but log mod x plus 2. Log mod x plus 2 plus c. Okay, so this is the integral value of that particular function. All right, I hope this method is clear to you. Now we are moving on to the next method. Okay. So this is the type 10. Okay. Type 10, that is integration by parts method. So in this method, if you are given two functions, okay, you have studied the properties of integrals, right? So if you are given a function like this, f of x, f of f plus g into dx, you can split this one as integral f dx plus integral g dx. If it was minus also, you can split it like f dx minus integral g dx. But if you are given a function like this, integral f into g dx, that is, if you are given a function in the form of the product of two functions. So can you split it like integral f dx into integral g dx? No, that is wrong. We cannot split it like integral f of x into integral g of x dx. So there is a rule for that. That rule is discussed in here. Integration by parts method, or you can say it is the product rule of integrals. Okay. So if you are given two functions u of x and v of x, then the product rule is like this. That is integral, here it is given, integral u into v dx is equal to, what is it? The u into integral v dx minus integral of derivative of u into integral of secant. Okay, so this is it, and here there is another dx. Okay, so this is the product rule. What is it? If you are given two functions, what you have to do is that first function into integral of second function, first function into integral of second function minus integral of derivative of first function, minus integral of derivative of first function into integral of second function. Okay, what is it? First function into integral of second function minus integral of derivative of first function into integral of second function. This rule, it is actually easy. If you do more problems on this, you'll be thorough with this rule. Okay. So that is given here, first function into integral of second function minus integral of the product of the derivative of first function into integral of the second function. All right. So we'll do a problem from this, then you will understand the rule. Okay. So for example, you take integral x into x into cos x dx, x into cos x dx. Is this the form a function into another function? Yes, x is a algebraic function, or you can say it is a polynomial function, and cos x is a trigonometric function. Cos x is a trigonometric function and x is a algebraic function. It is written as a product of two functions. Now what we have to do? We have to integrate it by using the parts method. Okay, so for that, how will you apply the rule? How will you apply the rule? Take this as the first function and this as the second function. Okay, so first function into, isn't it? First function into integral of second function, means here it is cos x, integral cos x dx minus integral of derivative of first function, which means d by dx of x. X is the first function here, into integral of second function, and one more dx for this big integral. Okay, you put one more dx for the big integral. Okay, so this is it. Now you know what is the integral of cos x. What is the integral of cos x? Derivative is minus sin x, so integral is sin x, right? So x into sin x minus integral of, what is the derivative of x? What is the derivative of x? With respect to x, it is nothing but 1 into, again, what is integral cos x? Integral cos x is sin x. Integral cos x is sin x into dx. Okay, so this is equal to x into sin x minus 1 into sin x is 1 into sin x is sin x. So sin x dx. Alright. Again, you know the integral of sin x. What is the integral of sin x? Derivative of sin x is cos x. So integral of sin x is minus cos x. So here there is already a minus. Now you put minus cos x plus c. Okay. In the last you put a c. So x sin x minus of minus will become plus cos x plus c. So this is the integral of the function x into cos x. Alright, moving on to the next question. One more example we'll do from this, applying that rule. That is integral x into e raised to x dx. X into e raised to x dx. Here you can see this is a algebraic function and this one is an exponential function. E raised to x is an exponential function, right? So how will you do it? By applying the integration by parts method. Okay, first function x into, okay, integral of second function minus integral of derivative of first function into integral of second function dx. Okay, that is first function x. What is the integral of e raised to x? E raised to x itself minus integral of, what is the derivative of x with respect to x? It is 1 into, what is the integral of e raised to x? It is e raised to x dx. Again, 1 into e raised to x is e raised to x itself. So this can be written as x into e raised to x minus integral e raised to x dx. So what is the integral e raised to x? Again, it is integral e raised to x itself. Okay, it is just e raised to x itself. So minus e raised to x plus c. So this is the integral of that particular function. Which function? X into e raised to x. All right. Now here, one more condition is that the order of the function is important. Okay, the order of the function means here there is a rule for choosing the first function and second function. That is, which function you should choose as the first function and which function you should choose as the second function. There is an order for that. That is, order is important. The order, the shorthand for that is given here. It's called as I-late rule. Okay, it is called as I-late rule. I-late rule. Okay, this means just the first letters of different type of function. That is, this is represent inverse trigonometric function. This is logarithmic function, algebraic function, trigonometric function. Then comes the exponential function. Okay, inverse function, logarithmic function, algebraic function means polynomial, trigonometric function, then exponential function. What is it? If you are given two functions and if there occurs an inverse function and a logarithmic function, then inverse function should give priority. That is, inverse function, you should choose inverse function as the first function. Okay, then you choose logarithmic function as the second function. If you are given an exponential function and a logarithmic function, okay, exponential function and a logarithmic function, which will we choose as the first function? You choose logarithmic function as the first function and exponential function as the second function. Here I have written some examples. Okay, so in the first question, it is x into cos x. We choose x as the first function. Okay, because it is an algebraic function. Cos x is a trigonometric function. Cos is a trigonometric function. So algebraic function should given first priority and then trigonometric function. So second function should be taken as cos x. If it is x square into e raised x, x square into e raised x square means algebraic function, e raised x means exponential function. So first function should be x square and second function should be e raised x. Okay, similarly all the other question, x square into log x, x square into log x. So which function you should choose as the first function? Algebraic. The one is algebraic, x square is algebraic, right? X square is algebraic and log means logarithmic function, right? So which should be given priority? Log. So first function should be log and second function should be x square. That is, if you are given a question like this, that is integral e raised x into log x, integral e raised x into log x dx. Okay, if you are given a question like this, which function you should choose as a first function? Is there any rearrangement required? Yes, definitely. Because here you can see, if you look at the isolate rule, here which functions are there? Exponential function is there and then logarithmic function is also there. E raised x and log x. So according to this, first log should be given priority, then e raised x. So you should rearrange this one as integral log x into e raised x dx. And then you should apply the parts method or product rule. Okay, that is first function into integral of second function minus integral of derivative of first function into integral of second function. All right. So moving on to the next part, that is it is like a sub part of that form. Okay, that is integration by parts method. That is e raised x into f of x plus f dash of x into dx is equal to e raised x into f of x plus c. Okay, this is a method and you have to study this. I'll explain it with the help of an example. So here you can see that it is f of x, and if the sum of the derivative is given there, then the integral of that function will be e raised x into f of x plus c. Okay, I'll explain it with the help of an example. That is integral e raised x into tan x plus sec square x, tan x plus sec square x into dx. Integral e raised x into tan x plus sec square x into dx. Okay, here if I choose f of x as tan x, what is the derivative of tan x? D by dx of tan x is equal to sec square x. D by dx of tan x is equal to sec square x. So if I choose tan x as f of x be tan x, then what is sec square x? It is nothing but f dash of x. F dash of x is equal to sec square x. We can write d by dx as f dash also, right? F dash of x is equal to sec square x. Now, is this of the form like this? E raised x into, now we can write this one as e raised x into f of x plus f dash of x into dx. Right? So, what will be the integral of this function? E raised x into f of x plus c. E raised x into f of x plus c. Here, what is f of x? Here, what is f of x? It is tan x, right? So the answer will be e raised x into tan x plus c. E raised x into tan x plus c. All right. I hope this is clear to you. We'll do one more question. Okay. So that is integral e raised x into sin x plus cos x. Integral e raised x into sin x plus cos x dx. Okay, so which function you should choose as f of x? If you take f of x is equal to sin x, what is the derivative of sin x? F dash of x. Derivative of sin x is cos x, right? Derivative of sin x is cos x. Now, is this of the form e raised x into f of x plus f dash of x? Isn't it? So what will be the integral value? It is nothing but e raised x into f of x plus c. Here f of x is sin x. So the value will be e raised x into sin x plus c. Okay, e raised x into sin x plus c. This will be asked for 1 mark question. So this is important. Okay. It's very easy if you know the derivatives of functions, okay? To choose a function as f of x and to know the derivative of those functions, then it will be very easy for you. All right. Now, so these are the 10 types of methods or types of integration. Okay, so we have completed the methods or different types. Now we are moving on to the next session of this chapter. That is the last session. So it's called definite integral. Okay. So integral itself, we can divide into two categories. That is, first one is indefinite integral and the second one is definite integral. Okay. Indefinite integral and definite integral. So till now we were studying about indefinite integral. Okay. We were studying about indefinite integral and now we are going to study about definite integral. So what is the difference? When is this indefinite integral become definite integral? Indefinite integral, we can write it like this: integral f of x dx. If a function f is given, then we can write the indefinite integral of f of x as integral f of x dx. This is known as indefinite integral. And this indefinite integral becomes definite integral when the x varies in a bounded closed interval. When x varies in a bounded closed interval. Here, for example, if I'll explain it with graphically, okay? So suppose that this is a function y equal to f of x. This is a function y equal to f of x. So till now we were directly integrating this function, that is x was not bounded. X was going up to infinity, right? It was not bounded. We were not mentioned about any boundary of that interval. Just we were given a function. Okay, so we were getting another function capital f of x. We were getting another function capital F of x. Now what I'm going to do is that I'm going to limit this function into a closed interval. That is, if I choose here a and points b, x equal to a and x equal to b, and I choose a line like this, which means the ordinates. I'm marking the ordinates, okay? So here you can see that this function y equal to f of x is bounded. It is bounded within a and b. It is bounded within a and b means the x varies from a to b. X varies only from a to b within a and b. Okay, that is the meaning of it. Then this integral, then if you are asked to find out or evaluate an integral which is limited between a and b, then the integral becomes integral a to b f of x dx. Integral a to b f of x dx. Okay, so indefinite integral itself, if the x varies in a bounded closed interval from a to b, then we can call that indefinite integral as definite integral. What is it called? Definite integral. So this is called as definite integral. Okay, this is definite integral. Integral a to b f of x dx. Okay, so here b is known as here b is the upper limit and a is known as the lower limit. Okay, a is the here it is called a is called as lower limit and b is called the upper limit of the integration. Okay, upper limit of the integration. Is that that much clear to you? So we understood that indefinite integral becomes a definite integral when x varies in a bounded closed interval. So we write integral a to b f of x dx. A is called as the lower integral and b is called as the upper integral. Okay, A is called as the lower limit and b is called as the upper limit. All right. Okay. Now we can evaluate this definite integral using two methods. Okay. We can evaluate the definite integrals using two methods. The first one is limit of a sum and the second method is antiderivative method. Okay, so here we will be studying only evaluation of definite integrals using antiderivative, and for that there is a theorem called second fundamental theorem of calculus. Second fundamental theorem states that if integral f of x dx, if integral f of x dx is equal to some capital F of x, if we integrate a function we'll get another function, right, f of x, then integral a to b f of x dx, integral a to b f of x dx is equal to f of x itself, but there is a limiting value, right, a and b. So we have to evaluate the function. First we have to evaluate the function at b minus, then you have to evaluate the function at a. So integral a to b f of x dx. This is our definite integral. What will be the answer? It is nothing but you integrate it as usual. Then you will get a function f of x. Then you put the upper limit. Then you subtract the value of the function and the lower limit. Okay. So this is known as second fundamental theorem of calculus. And you'll understand this on doing a problem. Okay. I'll take an example. So take this one, integral x dx. Integral x dx, it varies from 2 to 4. Let's take it, the lower limit is here. Lower limit is 2 and the upper limit is 4. Okay, so how will you evaluate this? How will you evaluate this? You integrate it as usual. You know how to integrate indefinite integral, right? X into dx. How will you do it? It is of the form x power n. Here n is equal to 1, right? Here n is equal to 1. So what you have to do? You have to add 1 to the power. Isn't it? 1 to the power. So this will become x raised to 2 by 2. X raised to 2 by 2, right? So the value is x raised to 2 by 2. But from 2 to 4, right? We are limiting this function. X square by 2 from 2 to 4. Now what you have to do is that first you put the upper limit. What is the upper limit? Upper limit is 4. First you put 4 here. So it is 4 square by 2. So it is 4 square by 2 minus what is the lower limit? Lower limit is 2. So in the place of x, you put 2. Okay, so this will become 2 square by 2. 4 square by 2 minus 2 square by 2. What did I done? What did I have done? That is, first you put the upper limit, then you minus the lower limit. Okay, in the place of x, you put the upper limit. So it becomes 4 square by 2 minus 2 square by 2. So this is equal to, what is 4 square? It is 16 by 2 minus, what is 2 square? 2 square is 4. 4 by 2. The denominators are same, so you can directly subtract, right? 16 minus 4 is equal to 12 by 2. 12 by 2 is equal to 6. Okay, what is it? 12 by 2 is equal to 6, which means here you are getting a fixed constant. 6 is a number, right? It is a constant number or a fixed value or a unique value, right? You are getting a unique value. But in the case of indefinite integral, if you do this question itself as an indefinite integral, what happens there? You get x square by 2 but plus c, right? There was a constant of integration. Here you are getting a number. You're getting a unique value or you're getting a constant itself. So you don't need to put a c over there. You're already getting a fixed value. This is, you're getting a fixed value, in which case indefinite integral you are getting a fixed value. Alright, I hope this much is clear to you all. So these are the basic concepts of definite integral. And if we explain it geometrically, we can say that actually, if by evaluating a definite integral, we are actually calculating the area under this curve. Okay, evaluating a definite integral means we are calculating the area under this curve y equal to f of x, then the ordinates x equal to a, x equal to b, and our x-axis. This is our x-axis. This is the ordinate a. This is the ordinate b, and this is the curve y equal to f of x. So actually we are calculating the area under this curve. What does that mean? Integral a to b f of x dx is nothing but it is just the area which is bounded by the curve y equal to f of x within the limits a and b and the x-axis. Okay, so this concept is applied in the next chapter, that is application of integrals. All right, I just mentioned it, the concept of definite integral. Now we are moving on to some problems. Okay, we'll do some problems from definite integrals. So the first question is integral 4 to 5, integral 4 to 5 e raised x into dx. Integral 4 to 5 e raised x into dx. Okay, so how can you evaluate this one? Integral 4 to 5 e raised to x dx. You integrate it as usual, so you will get e raised to x. Then from 4 to 5. Then from 4 to 5. So you get e raised to, first you put in the place of x the upper limit. Upper limit is 5. So e raised to 5 minus, then you put 4 in the place of x. That is the lower limit is 4, right? So e raised to 4, e raised to 4, you should not put plus c. Okay, this is the value. Definite integral you should not put plus c. All right, e raised to 5 minus e raised to 4 is the answer. Now moving on to the next question. Integral 2 to 3, integral 2 to 3, 1 by x into dx. Integral 2 to 3, 1 by x into dx. So this will become, what is the integral of 1 by x? Integral of 1 by x is log mod x plus c. Log mod x plus c. So here also it is log mod x itself, but we have to evaluate it from 2 to 3. Okay, now what you have to do? You have to put 3 and 2 in the place of x, right? So first you put log mod 3 minus log mod 2. What is mod 3 and mod 2? Both are positive values, so this is equal to log 3 minus log 2. So this can be written as log of 3 by 2, right? Log a minus log b can be written as log of a by b, right? So this is the answer of that particular definite integral. Now the next section is definite integral. We are evaluating definite integral by substitution method also. So in some cases we can directly integrate. So we'll be using the method substitution. That is, we have already studied that method, but here we are applying the limit for functions. Okay. So the first question is integral 0 to 1 tan inverse of x by 1 plus x square into dx. Can you integrate it directly? Tan inverse x by 1 plus x square. We can't integrate directly. So we have to make some kind of substitution here. So for which function I'll make the substitution? If I give tan inverse x is equal to u. If I give tan inverse x is equal to u, what happens? Tan inverse x is equal to u means find the derivative. What is the derivative of tan inverse x? 1 by 1 plus x square. 1 by 1 plus x square is equal to du by dx. And if I take dx to the other side, 1 by 1 plus x square into dx is equal to du. Right? Right? Now this can be written as integral. This is same as integral tan inverse of x into 1 by 1 plus x square, right? 1 by 1 plus x square into dx. So we can replace this tan inverse x with u and 1 by 1 plus x square into dx with the du. But in the case of definite integral, you have to change this limit also. The lower limit and upper limit should be changed. Why? What is the reason? Because this is the limit of the variable x. Right, the function was in variable x. So they have given the limit of the variable x. X varies from 0 to 1. The variable x varies from 0 to 1. But now we have substituted tan inverse of x is equal to u. U is another variable. So we have to find from where to where u is varying. When x varies from 0 to 1, we have to find out from where to where is u varying. Okay, so for that, what will we do? Here we know x is equal to 0 is the lower limit, right? Now we have to find out the value for u. What is u? U is tan inverse x. Tan inverse x. Okay, so this is equal to tan inverse of 0. Tan inverse of 0. Which value of theta? For the function tan will give you 0. Tan 0 is 0, right? So tan inverse of 0 is equal to 0. So the problem for this chapter is that most of the previous concepts, including inverse trigonometry, differentiation, and many concepts, trigonometric identity, all these concepts gets mixed with this chapter. So if you study all those concepts, then you will find this chapter easy for you. All right. So this is for the value when x is equal to 0, we have got u equal to 0. Now when x is equal to 1, you get u is equal to tan inverse x, right? So tan inverse 1. So which value of theta will give you tan theta equal to 1? Tan theta is 1. For which value of theta? It is pi by 4, right? Tan pi by 4 is equal to 1. So tan inverse of 1 is pi by 4. Now we have got the limit of the variable u. Okay, so we can replace the 0 as 0 itself, right? 0 is 0 and x equal to 1, then u is equal to pi by 4. So 1 will become pi by 4. 1 will become pi by 4. Now tan inverse x you can replace as u, and 1 by 1 plus x square dx you can replace as du. Now can't you integrate this one? Can't you integrate? What is integral u du? What was integral x dx? Integral x dx means x square by 2, right? Similarly, what is integral u du? The only difference is the variable has changed, right? So this will become u square by 2, u square by 2 from 0 to pi by 4, u square by 2 from 0 to pi by 4. Okay, so this one you put the upper limit, that is pi by 4 the whole square by 2 minus 0 by 2, right? 0 by 2 is 0. So this one if you simplify, what will happen? Pi by 4 the whole square means it is pi square by, it is actually pi square by 16. Okay, pi square by 16 divided by 2, divided by 2. So this is pi square by 16 into 1 by 2, right? So this is equal to pi square by 32, pi square by 32. Alright, so that is the value of that particular integral, that is integral 0 to 1 tan inverse of x by 1 plus x square into dx. Alright, now the last section is properties of definite integral. Okay, it is properties of definite integral. So these are the, here we studied properties for indefinite integral, right? Similarly, there are some properties for definite integral also. It is mentioned here. So the first one is a definite integral does not depend on the variable of the integration. That is, here you can see that integral a to b f of x dx is equal to integral a to b f of y dy. That is, even if we change the variable, there is no difference happening to the definite integral. If I explain it with the help of an example, you consider integral 0 to pi by 2 cos x dx. Okay, integral 0 to pi by 2 cos x dx. The function is in the variable x. Okay, so the operator is dx. The function is in x, so the operator is dx. Okay, so that's it. What is the integral of this function? We know integral of cos x is equal to sin x, right? Integral of cos x is sin x, but it is varying from 0 to pi by 2. It is varying, x is varying from 0 to pi by 2. So upper limit, next step is put the upper limit minus lower limit in the place of x, right? Sin pi by 2 minus sin 0. What is sin pi by 2? Sin pi by 2 is 90. 90 is 1. Sin 0 is 0. 1 minus 0. So that is equal to 1. So integral 0 to pi by 2 cos x dx is 1. Okay. Now what if I took cos y dy? Okay, the same question itself. If I took integral cos y dy, here the variable is x. So we choose the operator dy. The same limit. Okay, it is from same limit 0 to pi by 2. What will be the answer for this? Again, it will be sin y. Isn't it? Sin y varying from 0 to pi by 2. It is varying from 0 to pi by 2. Now you put sin pi by 2. Then minus sin 0. Upper limit minus lower limit. Again, what is the sin pi by 2? 1 minus what is sin 0? 0. This is equal to 1. Same answer, right? Integral cos x dx from 0 to pi by 2 and integral cos y dy from 0 to pi by 2 both has the same answer. So it does not, a definite integral does not depend on the variable of integration. You can choose x, y or t, all will give you the same answer. That is the first property. The second property is that in the definite integral we can interchange the limit. Okay, interchange the limit means here it is integral a to b f of x dx. If I want to change it from b to a, we can do it, but you have to put a minus there. Okay, that is minus b to a. So here you can see that the limit is interchanged, right? So a become b and b became a. Okay, so what is the difference here? There is a difference of minus. Okay, integral a to b f of x dx is equal to minus integral b to a f of x dx. All right, this is the second property. And now, moving on to the third property. Third property is this one. Integral a to b f of x dx can be splitted as integral a to c f of x dx plus integral c to b f of x dx. Okay, that is we can split the integrals when c is a point between a and b. When c is a point between the points a and b, then we can split the integral. That if we are asked to find out the integral of a to b f of x dx, we can split it like this. Integral a to c f of x dx plus integral c to b f of x dx. Okay, now moving on to the fourth property. This is integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. Here what is happening? Here a and b are the lower limit and the upper limit. So if you are asked to find out integral a to b f of x dx, the result is same as integral a to b adding the upper limit and lower limit, that is a plus b minus x into dx. Okay, from this you can derive this result also, that is Here integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. That is an important result. How will you derive it this from this result? Here you can see that in the place of a it is 0 and in the place of b it is a. In the place of b it is a. According to this theorem we can write integral 0 to a f of x dx as according to this property. How will you do it? This is equal to, this is same as integral 0 to a upper limit plus lower limit minus x. Here upper limit is a and lower limit is 0. So this is equal to f of 0 plus a minus x into dx. Right, 0 plus a minus x into dx. So this will become integral 0 to a. What is 0 plus a? A, right? So f of a minus x dx. So we can write integral 0 to a f of x dx as integral 0 to a f of a minus x into dx. Okay, so here we'll do a problem related to this property. Okay. That is, if you are asked to calculate the integral 0 to pi by 2 root of sin x by root sin x plus root cos x. So do you know how to integrate this function? Root sin x by root sin x plus root cos x dx. Or else you can write this one like this also. Okay, so 0 to pi by 2. Root x means x raised to 1 by 2, right? So root of sin x means sin x raised to 1 by 2. Or you can write sin raised to 1 by 2x, right? Sin raised to 1 by 2x. Divided by sin raised to 1 by 2x plus cos raised to 1 by 2x dx. Okay, the same question we can write this way also. So do you know how to evaluate this integral? No. So first we put I equal to this one question, that is 0 to pi by 2. 0 to pi by 2 root sin x divided by root sin x plus root cos x into dx. Root cos x into dx. Okay, now we are going to apply the property that we have studied now. That is integral 0 to a f of x dx can be written as integral 0 to a f of a minus x dx. That is, if this one is 0 and this one is the upper limit, then we can write it as f of a minus x, upper limit minus x. So here upper limit here in the place of a it is pi by 2, right? So I'm going to replace this as integral 0 to pi by 2 root of sine of pi by 2 minus x, sine of pi by 2 minus x divided by root of sine of pi by 2 minus x plus root of cos of pi by 2 minus x into dx. Okay, so what is the value of sine of pi by 2 minus x? Sine of pi by 2 minus x means it is in the first quadrant, right? Pi by 2 minus x. So it is positive. So since it is pi by 2, co-function come, right? So this will become integral 0 to pi by 2. Sine of pi by 2 minus x will become cos x. So it will become root of cos x divided by root of cos x plus the second term was cos of pi by 2 minus x. Cos of pi by 2 minus x, the co-function of cos is sine. So it will become sine x, right? So this will become sine x, root of sine x dx. Now this was our I, right? We started from I and we got this one. So this is equal to I. Okay. Now we are adding this one. Let's mark this as 2 and where was our I? So this is the first one. So we are going to add these two. Okay, that is I plus I. I plus I. I plus I means 1 plus 1, 1 plus 2 will give you I plus I, right? That is 2I. 2I is equal to, the first one was integral 0 to pi by 2 root sin x by root sin x plus root cos x. And the second I that we got now is root cos x by root cos x plus root sin x. Okay. So this is 0 to pi by 2 root sin x divided by root sin x plus root cos x dx plus integral 0 to pi by 2 root cos x root cos x divided by root sin x plus root cos x into dx. Okay, so here you can see that the denominators are same, root sin x plus root cos x, right? So here this was cos x and sin x. Since it is addition, both are same, right? So we can add the numerator. So this one you will get 0 to pi by 2 root sin x plus root cos x divided by root sin x plus root cos x. Okay, so what is the numerator and denominator are same. So this is integral 0 to pi by 2 1 dx. What is the value of 1 dx? Integral 1 dx, it is x, right? So x from 0 to pi by 2. X from 0 to pi by 2 means pi by 2 means pi by 2. In the place of x, you put the upper limit minus lower limit, right? So since it is x, pi by 2 minus 0, that is pi by 2, which means 2 into I. 2 into I is equal to pi by 2. So what is the value of I? I equal to pi by 2 into 1 by 2, that is pi by 4. Pi by 4. So what is the value of that particular integral? It is pi by 4. Now if you are asked to find the integral of this function 0 to pi by 2 sine raised to 3 by 2x divided by sine raised to 3 by 2x plus cos raised to 3 by 2x dx. What will be the value of this particular definite integral? It will definitely be pi by 4. If the limit is from 0 to pi by 2 and if the powers are same, then the value will be pi by 4. You can do it as we have done in the previous case. Okay, that is you put in the place of x you put pi by 2 minus x and solve it, then we'll get the answer as pi by 4. And if you are asked a question like this, integral 0 to pi by 2, in the place of numerator, if it is cos, okay, that is cos square x divided by cos cube x divided by sin cube x plus cos cube x. Okay, the denominator should be sin plus cos and the power should be same and the limit should be from 0 to pi by 2. Then the answer will be pi by 4. Okay, if it is of sine raised to 4x divided by sine raised to 4x plus cos raised to 4x from 0 to pi by 2, what will be the answer? It is nothing but pi by 4. Okay, this is also an important result from this chapter. Okay, now we are moving on to the next property. So this is our sixth property, that is integral 0 to 2a f of x dx can be splitted as integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. What is this 2a? 2a is our upper limit. 2a is the upper limit. So we can split this integral as integral 0 to a f of x dx, that is a is half of 2a. Okay, plus integral 0 to a, but here it is f of 2a, upper limit minus x into dx. Okay, so the next property is integral 0 to 2a f of x dx is equal to 2 into integral 0 to a f of x dx if f of 2a minus x is equal to f of x, and if f of 2a minus x is equal to minus f of x, the function takes the value 0. Okay, this can be proved using this property. Okay, that is, here we know integral 0 to 2a f of x dx is equal to, we can split like this. According to this property, we can split as 0 to a f of x dx plus integral 0 to a f of 2a minus x into dx. Okay, we can split it like this according to this property. Here you see the second property, that is integral 0 to 2a. Now if you choose f of 2a minus x is f of x. Okay, the first part. Okay, the first part, if you choose f of 2a minus x is f of x. F of 2a minus x is equal to f of x. Now what happens? Integral 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus integral 0 to a, here f of 2a minus x is, we have chosen it as f of x, right? So this become f of x dx, right? 0 to a f of x dx plus 0 to a f of x dx can be written as 2 into integral 0 to a f of x dx. 2 into integral 0 to a f of x dx. That's what written here. 2 into integral 0 to a f of x dx. Now what happens if I choose f of 2a minus x, that is the second part. F of 2a minus x is equal to minus f of x. If it is minus f of x, now what happens here? This one will become, the second part will become, instead of f of 2a minus x, this will become integral 0 to a f of minus f of x, right? F of 2a minus x is minus f of x. It will become minus f of x dx. If I take this minus outside, this will become minus, right? Which means 0 to a f of x dx minus integral 0 to a f of x dx. What is the value? It is nothing but 0. It is nothing but 0. Okay. So here I have forgot to mention a property that is very important. Integral a to a f of x dx. Integral a to a f of x dx is nothing but 0. If you put the same limit, f of a minus f of a, what will be the value? It is 0. You can think it using common sense, right? Integral a to a f of x dx is equal to, will be 0. Now we need the last property. Before discussing the last property, we have to discuss what is an even function and what is an odd function. Okay, even function and odd function. Even and odd function. So what do you mean by an even function? Even function means the functions which are of the form f of x is equal to f of minus x is equal to f of x itself. And the functions which are of the form f of minus x is equal to minus f of x, those functions are called as odd function. So what is it actually? If you take the function x square, okay, x square, if I put f of minus x, okay, f of x is equal to, you choose f of x is equal to x square. Okay, what is f of minus x? F of minus x is equal to minus x the whole square. What is minus x the whole square? X square. X square is f of x, right? Here we have got f of minus x is equal to f of x. So we can say that x square is an even function. And if you choose f of x is equal to x raised to 4, x raised to 4, then also if you do it like this, we get f of minus x is equal to f of x. So x power any even number will give you f of x is f of minus x is equal to f of x. So such functions x power 2, x power 4, x power 6, etc. are even function. Other than this, if you take f of x is equal to mod x, f of x is equal to mod x. Okay, what is f of minus x? F of minus x is equal to modulus of minus x. So that is again mod x, which is equal to f of x. So mod x is also a even function. Now what about f of x is equal to sin x? F of x is equal to sin x. If you put f of minus x, that is sine of minus x. According to sine of minus x is equal to, I'm sorry, cos x. Sin x is an odd function. You take cos x, okay? F of x is equal to cos x. So cos of minus x is equal to cos x itself. Okay, cos of minus x is cos x. So cos x is also an even function. Now, can you say some of the examples for odd function? Odd function means if you put f of minus x, then you will get minus f of x, negative of f of x. For example, you take x cube, f of minus x is equal to minus x cube, right? Which means minus f of x, minus f of x. Okay, for example, if we take f of x is equal to sin x and tan x also. F of minus x is equal to sine of minus x, that is minus sin x, that is minus f of x. So sin x is also an odd function. So I hope you understood what an even function and odd function is. Now we can discuss the last property of this chapter. So it is integral minus a to a. It is from minus a to a. Okay, minus a to a, f of x dx can be written as 2 into integral 0 to a. It was from minus a to a. So the simplification becomes easier if you apply this property. You can write this one as integral 0 to a f of x if f of x is an even function. F of x, when f of x is an even function, we can write the value of this definite integral as 2 into integral 0 to a f of x. Okay, f of x dx. Now, if f of x is an odd function, then it is very easy. What will be the value of integral minus a to a f of x dx? It will be 0. So for example, f of x, sine is an odd function, right? So integral minus pi by 2 to pi by 2. Let's take a as pi by 2. Minus pi by 2 to pi by 2 sine x dx. What will be the value of this function? According to the property, since sine x is an odd function, it is varying from minus a to a. That is minus pi by 2 to pi by 2. The value of this integral is nothing but 0. It is nothing but 0. Okay. If you take sine 7 power x. Okay, sine raised to 7x. That is an odd function, right? Odd powers of sine is an odd function. So then also the value of the integral will be equal to 0. All right. I hope this much is clear to you all. So today we discussed about integration by partial fraction, then integration by parts method, that is the product rule, and we studied what is a definite integral. Then we studied how to evaluate a definite integral, and we also studied the properties of definite integral. So that's all from this chapter. We have completed the portion. So from the beginning, if we discuss, we studied what is an integration. That is, integration is the reverse process of differentiation, right? So if you get an value for a value after integrating, then that function is known as the integral or antiderivative. We are getting a family of antiderivative. Then there is a constant of integration. Then we studied some of the standard integrals, right? These things you have to study, okay? And you can easily memorize it by connecting. Then we studied about the properties of integrals, right? Properties of integral. Then we studied different methods, right? Different methods of integration. Okay, from the first type to the last type. That is, there are 10 types for the integration. When we classify, we can mainly classify it as 3. That is integration by substitution. That itself we divided into 8 parts. Then integration by partial fraction, then integration by substitution, and then we studied what is a definite integral. Okay, I hope it was useful to you all. If you have any doubt regarding any method, you watch the video again. Since we have a time constraint, we cannot explain all the problems from each of the session. So you rewatch it again, then you will understand the different types or different methods of integration. All right. I hope the session was useful to you all. Thank you.